Hey students, today we're going to do a little bit of math, so the very first thing that you need to do is make sure you have a calculator. If you don't have a calculator, please go grab it, hit pause on the video, go get a calculator, come back because we definitely need it today. Alright, today's topic is, we're on page 25, pH and pOH. Today's date is 5/4. We're going to start off with some vocabulary. Alright, kind of get some information out of the way before we get rolling. Today's topic is pH and pOH. Alright, so we're going to start with our hydronium ion concentration. If you look at the H3O+, it looks like a water that has a hydrogen attached to it, which is absolutely correct. So we're talking about the concentration of an acid. And when we talk about that concentration of an acid, we're talking about how many moles of acid are dissolved in water, so per liter. All right, so we're talking about how strong an acid is or how much acid there is in it. If we look at the next one, hydroxide ion, OH-, this is the one that's going to tell us our concentration of a base. All right. Now, those are very small numbers. Our concentrations tend to be very small numbers. They tend to be like, they use scientific notation like -5, -6, -7. So those numbers are not very easily used and kind of not very friendly. So what they came up with is a pH scale. And the pH scale tells us our strength. The pH scale tells us the strength of an acid. And it's based on that concentration. We'll see a formula in just a little bit that shows how they're related, but it's the strength of our acid, and it makes it numerically easier to see because it's like numbers that we're used to, like 4.12 or 7 or something like that. All right. pOH then is the strength of a base. I know you're surprised. Strength of a base. All right. Kind of other things that you might know or you might not know. Our acid is something that has a pH of less than 7. So if something is an acid, it has a pH of less than 7. If it is a base, it has a pH greater than 7. And that's how we judge an acid or a base. pH less than 7, it's an acid. pH greater than 7, it's a base. All right, if it's right at 7, we consider that a neutral. And yeah. All right, not that we see a lot of those. Pure water should be neutral, but the water that comes out of our tap is not often neutral. Okay, now let's roll down our formulas here. These formulas are going to be our best friend for the next couple of weeks. All right, so these 4 formulas, I want you to look at them. You don't have to memorize them, obviously, but my suggestion is if you have a Post-it sitting around, write these formulas on there. Tomorrow we'll add 2 more, but just to get familiar with these, but put them somewhere where you can find them and be able to access them fairly easily. So the first one is pretty straightforward and pretty easy to do, honestly. pH plus pOH equals 14. We've got the second one, which says our hydronium ion concentration times our hydroxide ion concentration equals 1 times 10 to the negative 14th. We have pH equals the negative log of our hydronium ion concentration. And we have pOH equals the negative log of our hydroxide ion concentration. Those are the 4 that we're going to learn how to use today and practice with today. So let's go ahead and jump into an example and see what we got. Guess I wanted to keep the highlighter going. All right, so what we do to figure out which formula do we use, because I just gave you 4 of them, how do we know which one we use? Well, let's look at the problem and see what it says. The problem says if the pH is 3.45, what is the pOH? Well, what do we have? We have pH and pOH. So the only formula that has that is that very first one. So that's the formula we're going to use. So the formula we're going to use, pH plus pOH equals 14. That's our formula. And we're going to plug in 3.45 for our pH. So we're going to put 3.45 plus our pOH equals 14. And to get pOH by itself, we're going to subtract 3.45 from each side. 3.45, that isolates the pOH, and that gives me a pOH of 10.45. And right now you're thinking, Miss Griffith, I didn't even really need a scientific calculator for that. You're right. But the next one, you'll definitely want it, I promise. So I'm going to change colors here. Let's go to purple. All right. Our next problem, I'll have to shrink this down just a little bit. All right, so we've still got our formulas up there that we can see. And this one says, what is the pH if the hydronium ion concentration is 2.22 times 10 to the negative second? So the things that we have or know is hydronium ion concentration, and we're looking for pH. So the formula that has both of those in there is that one right there. pH equals the negative log of our hydronium ion concentration. So that's the one we're going to use. So I'm going to scroll up. pH equals our negative log of our hydronium ion concentration. All right, so let's plug our numbers in. pH equals negative log of 2.22 times 10 to the negative second. Now here, when we type it in our calculator, it gets a little more difficult, right? Because it's been a while. And we've actually never typed in logs in our calculator in this class. Maybe you have in another class, so that'd be awesome. All right, I'm going to be modeling using a Texas Instruments calculator. All right, if you're using your iPad, we can figure that out as well. But for right now, let's just roll with the Texas Instruments one. All right, so first thing that we're going to do is we're going to type in the negative sign. Not the minus sign. Do not put the subtraction sign in. You're going to put the negative sign in. It's the one probably with parentheses around it. Then you're going to type the log button, which is up in the top somewhere, probably on the left-hand side. All right. And when you do that, it says log and then a parentheses. Okay. Then we're going to type our 2.22. All right. Next, to get that times 10 to the, remember this is where we use the E button, all right? On Texas Instruments, you usually have to hit second something. On the yellow ones, it's second comma. On the little blue ones, mine's second x to the minus 1. But that's where we get that little E there. And then we're again going to type a negative sign, 2, and then you can just hit equals, all right? So to kind of go through that slowly, we've got our negative sign. Then we've got the log button. Then we're going to type 2.22. We're going to get the E button and then -2 and then hit equals. When you do this, the answer that you should come up with is 1.65. 1.65. Please check and make sure that you got that on your calculator and you're understanding it and you typed it in correctly. All right. Now, our pH has no label. All right. So we're just going to say pH equals, has no labels. And for right now, we're going to ignore the sig fig situation. But I want you to just to keep 2 decimals in all your sig figs, or in all your pHs and pOHs. Okay. Sound all right? Okay, and now just to kind of check back, is this an acid or a base? If we have a pH of 1.65, is it an acid or a base? You are correct. It is an acid because it has a pH of less than 7. Up here we said a pH less than 7 is an acid. Okay. All right. Let's do the last question there. We're going to have to make this somewhat small. Okay, there we go. Now, what we have here, this one is actually a 2-stepper. All right, but I think we can handle it. It says, what is the pH if the OH is 1.11 times 10 to the negative 10th? If we see up here, we don't have one that takes us directly from OH to pH, right? We can go from OH to pOH, like this one right there, and then go to pH, right, from pOH. We could also, the other way we could go is go from OH, right, change colors here, let's go orange. We could go from there to the hydronium ion concentration, and then from the hydronium ion concentration to here, All right. Man, I'm all over the place, right? But let's go ahead and do the green one first, and then we'll come back to, we'll do the other one as an example if you want to, but you can shut off the video before that time if you so choose. All right, so the first one we're going to do is that one. So the two formulas that we need, scroll this up just a little bit. The first formula that we're going to use is pOH is equal to our negative log of our hydroxide ion concentration. And then the formula that we're going to use is pH plus pOH equals 14. All right, so that's where we're going to get started here. All right, so let's go ahead and get rolling. All right, so the first formula we're going to use, I'm going to expand this up so we can hopefully write a little neater. pOH is equal to the negative log of our hydroxide ion concentration. All right, that should technically be a bracket. All right, so let's plug it in. Negative log of 1.11 times 10 to the negative 10th. All right, remember typing in our calculator, negative sign, log button, which brings up a parentheses and log. And then we're going to type in 1.11. Then we need that E button, negative 10, and hit equals. All right, and that's going to be our pOH. So let's take a second to type that in. Negative log 1.11 E negative 10, and then hit equals. The number that you should come up with is 9.95. There's some other numbers there, but that 4 keeps the 5 where it is, so we just leave it as that. All right, so that was part 1. We're not quite done. We've got to pOH, and we need to get to pH, which is where we're going to use this formula now. And we know that pH plus pOH equals 14. So if we plug in 9.95 right there, we can find pH. pH plus 9.95 equals 14. And we're going to subtract 9.95 from each side. And that will give us our answer. And our pH then, getting onto another page, but I think we'll be okay. pH is going to be equal to 4.05. 4.05, and there's our pH. All right. If you felt comfortable with that, that's awesome. Just stay right there and head on out. If you would like to see the other method, I'm going to stay on and do that. It makes the video a little bit longer, but you're not required to watch this part. All right. The other formulas that we could have used, all right, is the hydronium ion concentration times our hydroxide ion concentration is equal to 1 times 10 to the negative 14th. All right. We know our hydroxide ion concentration, so we say H3O plus, and then we've got our 1.11 times 10 to the negative 10th is equal to 1 times 10 to the negative 14th. And if we're trying to isolate the H3O, we're going to put 1.11 times 10 to the negative 10th there. 1.11 times 10 to the negative 10th. Remember, typing this in our calculator, we need 1e negative 14. Then divide sign, 1.11 e negative 10. And then equals. And this should give us, depending on your calculator, it might give you a couple of different things. It might give you, my calculator gave it to me out of scientific notation, so it looks like we have 4 zeros and then 9009. It might have also given it to you in scientific notation, 9.009 times 10 to the negative 5th. Either way, still works out. All right, and that's our hydronium ion concentration. So the other formula that we need is the one we have start up there, kind of scroll back up there and look at that, is the pH equals the negative log of our hydronium ion concentration. So pH equals the negative log of our hydronium ion concentration. And so we just plug that number in. So we're going to type in negative log 9.009 e negative 5, and then hit equals. And that'll be our pH. And you should get the same answer, shockingly enough. pH equals 4.05. It actually says 4.045, but then you just round it up and you're there. Okay, hope that helps. If you have any questions, please feel free to email me. All right, talk to you later. Bye.